Introduction and Review of Chemistry 20 Skills, Proton, Neutron, and Electron Calculations. Isotopes and proton-neutron calculations. Before we begin, it's important to review from grade 9 science that the number of the element on the periodic table equals the number of protons in that atom's nucleus, and that protons and neutrons both have a mass of 1 atomic mass unit. So if we see the symbol 12,6 carbon, also could be written as carbon-12, we are told that this atom of carbon has 12 atomic mass units. And knowing that since it is carbon, and carbon is number 6 on the periodic table, that means this carbon atom has 6 protons. And if it weighs 12 atomic mass units, it must also have 6 neutrons. Likewise, if I have 14,6C, which is carbon 14, we are told that this weighs 14 atomic mass units. Again, carbon is number 6, so we know of those 14 atomic mass units, 6 are protons, which means this atom of carbon has 8 neutrons. Carbon-12 and carbon-14 are both carbon, but weigh different amounts because they have a different number of neutrons in their nucleus, and that makes these two atoms isotopes. Isotopes of one another. Same element, thus same number of protons, but differ in the number of neutrons. I want you to pause now and take these notes down. Now for the examples. Example 1. How many protons and electrons in a potassium ion? So the name of the formula is potassium ion. And I remember from grade 9 and grade 10 and grade 11 that if it ends in the word ion, that means it has a positive charge. I look up potassium on the periodic table. It's on the far left-hand side and it's number 19. I'm going to write K plus because as I can see, potassium can only take a +1 charge. So potassium ion is K with a +1 charge. I'll write my number of protons and electrons. Next to protons, I like to put a positive. Next to electrons, I like to put a negative. And potassium is number 19. So that means it has 19 protons. And if it has 19 protons and there's a positive charge, that means it has to have 18 electrons. Just to double check, protons are positive. I have more positives than negatives by 1. Everything is all good. My answer is correct. Example 2. What is the identity of an ion that has a +2 charge and 48 electrons? This time I will start by writing protons and electrons. Again, I like to put a positive next to proton, negative next to electrons. I'm told I have 48 electrons. And since, again, I have a positive charge, that means I'm going to have 50 protons. Now, I have more positives than negatives, and I have 2 more positives than my number of negatives, which is what I want to have because I was told it has a +2 charge. So I'm going to grab my periodic table and I'm going to look up number 50 on the periodic table. And that is Sn, so my answer is Sn with a +2 charge. If on the quiz you write only Sn without the charge, that will be marked incorrect. So I have Sn with a +2 charge. I could also answer by using the proper name for Sn2+, and that is tin2 ion. Now, at the bottom of the square, it has 2 or 4, and that is why I require a Roman numeral. If there was only one number at the bottom of the square, I do not need a Roman numeral. But since tin can be a +2 or a +4, I must include the 2 in the Roman numeral. So when someone reads it, they will say tin ion, positive charge, it's got a +2. If I wrote just tin ion, they would say, I looked at the periodic table, is that Sn2+ or Sn4+? I don't know. It's going to have to be included in the name. And that brings us to the end of this short lesson.